Today we'll start the probability portion. This is a bit tricky topic. Due to several reasons, we will see each of that. And I'm not wrong if I say that it's a highly fair topic. And usually students just leave this topic. And let's get started with probability. What is it? Is a probability? It is basically, you can say this, a ratio or a fraction in which in the numerator we have total number of success, and we divide this with the total number of outcomes. Okay, so in the numerator we have total number of success, and in denominator we have total number of outcomes. And we can also say this, the desired outcome divided by total outcomes. Okay, so this probability usually it is represented with P, and this probability must have to be greater than 0 or equal to 0 or less than or equal to 1. And 0 mean there is 0% chances of occurrence. And 1 mean there is 100% chance of occurrence. So that is certain that that event will likely to happen. And in between, and this is basically in decimal form, we have, for example, 0.24. That means there is a 24% chances of occurrence of that event. Just to get started, let's see a very basic example. For example, if someone rolls a fair dice, we will see afterward what is a fair and unfair dice. A person roll a fair 6-sided dice. Let's make it very simple. 6-sided dice. You can call this die because die is a plural form. Once, what is the probability of rolling a 2 on the first side? Okay, so someone is rolling a fair 6-sided dice once. What is the probability of rolling as 2? By 2 I mean 2 on the upper side when we roll. So what are the total outcomes? Total outcomes are 1, 2, 3, 4, 5, and 6. So there are 6 options available. So total is 6, and required outcome. Success, the outcome having success is 2, and that is only one way. So what is the probability? Probability of getting 2, that will be one way in which we get 2 and out of total. So probability of getting 2 on the upper side, that will be 1/6, right? This is just an idea. You can get this in fraction form or in the decimal form based what exactly the question asks. If the question asks in that you should write this in fraction form, just write this way. And the question asks you can write this in the decimal form, you can also write that way. One more thing, in the actual exam, if you write this 1/6, this is same as 2/12. You can write this way unless the question specify that you need to put into the least fraction form. Unless the question don't specify, you can just put 1/6 or 2/12. This is the same, right? Unlike the most of the exam, most of the prep companies, they only consider 1/6. But in actual exam, you can put 2/12, unless that is specified that you must put this into the least fraction form, right? Okay. The next thing is about the complement of a set. So what is it? Is a complement. That means all outcomes that are not the event. For example, if I say that if I consider a fair coin having two outcomes, head or tail, and having an equal probability of head 1/2 and of tail 1/2, right? So if I consider event having a head, that will be equal to 1/2 probability of half 0.5. If I take the complement of this event, that's mean I need to subtract this out of total. Total is 1, so its complement will be 1/2. Right? This is exactly the same concept which we use in the at least scenario, which we discussed in the last. This is just to give an idea. And if you want to see in terms of Venn diagram, because it is easier to visualize the scenario in Venn diagram by discussing the probability portion, that, for example, if this is event A, and if I want to discuss the complement of this event, that will be anything except this A. This will be the complement portion. Please mute yourself. Okay, so this was just an idea about the complement. And shall I move forward? Because these are very basic things I believe all of you should know. And probably all of you already know. Shall I move forward? Okay. We have discussed this. Okay, now the very important thing is the mutually exclusive events. You will see these terms mutually exclusive, independent event, dependent event while you deal with the probability portion. So let's see what exactly are these. First of all, let's see the mutually exclusive event. Two events are said to be mutually exclusive we can also call it disjoints if they can't happen or occur at the same time. So if I consider two events X and Y out of the total, so, and if I say that both of these are mutually exclusive, so what exactly I can say about these? The first thing I can say that event X can happen alone. The next thing I can say that event Y can happen alone, can occur alone. Can I say that event X and event Y can occur at the same time? Can I say this based on that both of these are mutually exclusive? Anyone? Already said that event X and Y are mutually exclusive. Now I'm saying that can I have both of these occurring at the same time? No. That is not possible. Because by definition, what is a mutually exclusive event? That if they can't happen at the same time, right? So if I consider two events as a mutually exclusive events, I can say that event 1 can occur alone. Okay, perfect. Event 2 can occur alone. But I can't say that both of these can occur at the same time. Just take an example to get an idea. Okay, one last thing. I can also say that neither event A nor event B can happen at the same time. I can also say that, but the only thing I can't say is that event X and event Y can occur at the same time. Okay, let's see one example to get an idea. For that, if we see this in terms of Venn diagram, so if this is event A, so, and this is event B, these are mutually exclusive because there is no overlap between them. And if I say that there is an overlap, this is event A, this is event B, there is overlap, these are not mutually exclusive. They can happen at the same time because there is some overlap. But in this is A, this is B, they are not overlap. We can say that A and B are mutually exclusive events. Okay, let's just to give you an idea, consider a case of a dice. Okay, just consider a very simple case to get an idea. For example, if considering, I'm trying to make things a bit simple so that every one of you can understand what is actually happening here. Considering a fair dice case, there are how much possibilities? There are 6 possibilities. One, 2, 3, 4, 5, and 6. And we are throwing ones, right? If I say that one event is that we are getting even number while after throwing the dice, and this is event A. Another event is we are getting an odd number. So can we call these events as mutually exclusive? Yes, because we can't have even or odd number at the same time. So if we even in the first event, event A, in which we are getting the even number, we could get 2, 4, and 6. And in the event B, we will get 1, 3, 5. There is no overlap, right? So these two events are mutually exclusive. They can't occur at the same time. Got the point? Now, if I consider another case, if I say that the same event A is I'm getting an even number when I throw a dice, when I roll a dice, and even B, if I get a number greater than 4. So now can I say that these events are mutually exclusive? No, because if for even I could have 2, 4, and 6, and for greater than 4 I could have 5 and 6. So there is overlap. So both of these can happen at the same time. So these are non-mutually exclusive events. Right? So in general, there are two categories. One is mutually exclusive and is not mutually exclusive. In mutually exclusive, they can't occur at the same time. In non-mutually exclusive, they could occur at the same time. Till now, everything is clear? If yes, then I'll move further.
Yes.
And in case of, again for remembering, in case of mutually exclusive, there is no overlap. If this is event A, this is event B. And in case of non-mutually exclusive, there must be some overlap. This is A, this is B, which is usually represented in the probability form as A intersection B, or A and B. There is some overlap, so these are non-mutually exclusive events. Okay, now let's move further and let's talk about the independent and dependent events. How can we define the independent events? Two events A and B are said to be independent if the fact that one event occurred does not affect the probability that other event will occur. In simple, you can say that in which the occurrence of one event does not affect the occurrence of other, right? To give you an example, consider an event in which we are rolling a die, and flipping a coin at the same time, right? Both of these are separate events. One is the rolling of die and other is the flipping of a coin. And if I say that first event is this is first event, this is second event, and first event is rolling of die and the second event is the flipping of coin. And in the first situation, in the rolling of die, we have 6 outcomes. And will that affect the flipping of coin in the next scenario, in the next event? No. The rolling of die is totally independent of the flipping of coin. Whatever the result of the outcome of this event, that will not affect the outcome of the other event. For example, if we are getting 1, so this will be 1 by 6, and if this is the fair coin, right, so that will be for head, probability will be 1 by 2, and for tail the probability will be 1 by 2. So for example, we are getting head, so their occurrence is not affected by the other, right? This is a concept of the independent events in which the occurrence of one event does not affect the occurrence of other event. This is a very important concept. And then one more thing, if both events are independent, if I say that event A and B are independent, that means if I take the probability of event A and event B, that will be just a multiplication of probability of A into probability of B. This was for the independent events. And just like we discussed a mutually exclusive at earlier, for that probability of A and B, this sign is usually called for and is 0 because there is no overlap, right? So this was idea about the independent events, right? And now let's see the dependent event. If we see the dependent event, again, if I define that in which the occurrence of one event affect the occurrence of other event. Okay, so if I say that I have a basket having 5 balls, in which 3 are green balls and 2 are blue balls, right? And if the question is that if we randomly select 2 balls, randomly selecting 2 balls, so from the basket, the question is what is the probability of drawing probability of picking a green ball first and then blue ball such that these are without replacement. So the very important takeaway in this question is these are without replacement. If you are picking one ball for finding the occurrence of next event, you can't include that ball in the subsequent event, right? I want to have idea about the with and without replacement, right? Yes. What is meant by with replacement? What is meant by without replacement?
Yes.
So in this first probability of drawing a green ball first. So we have 3 green balls and 2 blue balls. So in total we have 5. So what is the probability of getting a blue ball first? Getting a green ball first? That will be 3 out of 5, right? And the second is, and then we need to pick a blue ball, right? We how many blue balls? 2. Now whether this is 5 or whether this is 4. This is 4 because these are without replacement. We are not replacing the ball which we exactly earlier picked, right? So this is 3 by 5, this is 2 by 4, and we are considering both at the same time. That's why we will multiply this. So now why these are dependent event? In actual, the probability of getting a green is 3 out of 5, and the probability of getting a blue is 2 out of 5. But we are considering a case which is without replacement. So based on first scenario, the second scenario, the probability changes. This has to be 2 over 5, but this becomes 2 by 4. Right? So these are dependent events in which the occurrence of one event affect the occurrence of other event. And usually these are without replacement cases. Okay, so let's discuss further. And if we talk about there is a sort of confusion when a person say one event is independent and one event is one event is mutually exclusive. Never mix up these two events. Those are totally different things. In independent event, occurrence of one event does not affect the occurrence of other. And in mutually exclusive, both events can't occur at the same time. These are totally different scenarios. And just to give an example, if we consider a single coin, whether we will get head or we will get tail, right? So occurrence of one is not affecting the occurrence of other. But if we consider two separate coins, oh, sorry, this is a mutually exclusive case. If I consider a coin and there are two events that could occur, whether that is head or that is tail, right? So both can't occur at the same time. So these are mutually exclusive. But if I consider that if I take two separate coins, and let's suppose in the first, if I get head, so in the second there's equal probability of getting head or tail. This is independent of what I get in the first event, right? And the third difference is the AND scenario. Probability of A and B is just probability of independent A into probability of B. and mutually exclusive, this is equal to 0, right? And one last thing, in the dependent event, if I want to calculate the probability of A and B, that will be probability of A into probability of B after A. What is it that mean? That mean event A has occurred first. Now the probability of A will depend upon the probability of B will depend upon the probability of A. And we usually represent this with the conditional probability with this sign, right? That's mean the probability of B given the probability of A. We are finding the probability of B such that the event A has already occurred, right? So now let's discuss about the conditional probability. Let's discuss the conditional probability. And what is at least a conditional probability? In which we are finding a probability of event based on some event that has already occurred, in which chances of one event which is based on some other event which has already occurred, and usually this is represented, for example, if I taking the two events A and B, and if I represent this with the A/B, that's mean the probability of event A given that event B has already occurred. I can also say this conditional probability of A given B, right? And how we present this probability of A given probability of B, probability of A given B, that is probability of A and B, that is intersection of both divided by probability of B, right? Okay, if I take one example, before this, let's see if we have independent events. In independent events, we discussed that the probability of A and B will be just the probability of A into probability of B. And if I consider both are independent, so in that scenario, probability of A given B will be equal to probability of A into probability of B divided by probability of B, and this will equal to probability of A. So if both events are independent, then their conditional probability, which means probability of A given B, will be straightforward equal to probability of A. And if they are mutually exclusive, and in that I mean probability of A and B is equal to 0. So if I see that probability of A given B is equal to 0 divided by probability of B, so this will also be 0, right? So first scenario is for the independent events, and second scenario is for the dependent event. And to understand this, let's consider a Venn diagram. See this using a Venn diagram. And in Venn diagram, let's consider a case, first case, in which these are non-mutually exclusive events. That means there must be some overlap between them. And if this is A, this is B, and I say that their overlap portion is 3, this is 2, and this is, for example, 4. And if I see this, A is equal to 5, B is equal to 8, not 8, 7. Okay, so what will, if I say what is the probability of A given B? If I go with the formula, that is probability of A and B divided by probability of B. So if I see this, probability of A and B is this 3, and divided by probability of B. And what is it the total part? 4 plus 3, 7. So this is 3 by 7. And if I say that probability of B given A, that will be probability of A and B divided by probability of A. So this will be 3 by 5. Okay. And now you can see 2 other cases. If these are mutually exclusive, if these are mutually exclusive events, that's mean there is no overlap between them. As there is no overlap between them, so probability of A and B is equal to 0. If that is 0, so you can see any probability of A given B is also 0, and probability of B given A is also 0. And the last is if I consider that there is a maximum overlap. There is a maximum overlap. For example, if I say that B is inside of A, this is B, this is A, and this is 1, and this is 3. So if I say that probability of A given B, what will be that value? What is the overlap? That is 1. And what is the total for B? That is how much? Anyone? If I have 2 events, B and A, and for B that is 1, and for A that is 4. So what is the probability of A given B? Anyone?
1 by 4.
1 by 4. This is event B, and this is event A. Isn't this is 1 as well? Because probability of A and B divided by probability of B. And for B, this is 1. There's a maximum overlap. So this is equal to 1. But if I say that probability of B given A, because this is B, and in this situation, I choose B as 1 and A is 4, and with the overlap of 1.
Okay, so the B is inner circle.
Yeah, B is inner side.
Sorry, I thought it is like outer circle. The A is like outside.
And now if I see the overlap, this is 1. And now what is A? A is 4. So this is 4 when I considering B given A, and this is for A given B. This is in the form of the Venn diagram. We will discuss in detail when we'll see the questions, when we solve the question relevant to this, that how such question could be asked. Now is the very important thing for which we just build the base, that is or even or and event. If any one of you gone through the probability question, you must seen that probability of A or B or both, probability of A and B. These are very much common terms. And now let's see this based on each scenario, whether it is mutually exclusive or independent. First, let's see the probability of event A or event B. First of all, if you see the OR, as we discussed in the permutation and combination concept, OR is a keyword for addition, right? So things are very simple if you are considering the mutually exclusive case. In the mutually exclusive case, if again consider this scenario, this is A, this is B, there is no overlap, right? So probability of A and B is equal to 0. So in this scenario, if I take the probability of A or B, so that will be very simple, probability of A plus probability of B. Because there is no overlap, you are just adding both of these when you are considering probability of A or probability of B. But if we consider the non-mutually exclusive, if I consider a case of non-mutually exclusive, so that's mean in this scenario, there must be some sort of overlap between them. Let's call this probability of A and B. This is the probability of A and overall, and this overall is probability of B, this thing. And now if I say that, and one more thing, you must have seen these two terms, probability of A or B, or if I say that probability of A or probability of B, and if I write inside or both, so in some you will see probability of A or B, and in some you will see probability of A or B or both are same thing, right? So now in this scenario, if I ask probability of A or B, so what will be that? That will be just like the mutually exclusive case, probability of A plus probability of B. But there is an issue. The issue is we have counted this thing twice, right? So that's why we need to remove these things once. Now this is the probability of A or B. So the only difference in this from the mutually exclusive case that in this we are considering this twice because there is overlap. You need to just consider this only one time. And you can also see this way that if this is a Venn diagram, this is both. For example, this is A, this is B. This is only A, and this side inside is only B. So probability of A or B will be equal to probability of only A, probability of only B, plus probability of both, right? So you could be provided this way, or you could be provided this way. This is what you need to figure out. Okay, so this was for the A or B case. Now let's see the AND scenario. Which is usually represented by this sign. If I say that probability of A and B, right? Again, considering two scenarios. First scenario is mutually exclusive. In mutually exclusive, there is no overlap, so this will be 0. And now if I see the independent events, what we discussed earlier, that in independence event, the probability of A and B will be just the multiplication of their probabilities, probability of A into probability of B. And in last, if we see the dependent events, so if I say that probability of A and B, this will be equal to probability of B into probability of A given B, or I can say that probability of A into probability of B given A, right? With practice, you will understand what exactly are these. Okay, so now let's discuss the very important and highly tested thing, which will usually you will see in exam if you perform well in the first sections. That is, let's see 3 scenarios. First of all, in first scenario, if I say that probability of A is equal to 0.5 and probability of B is equal to 0.7, right? And if I say that which are the following could be the probability of A, let's say probability of A and B. Person is saying probability of A is given, B is given. And we are asking what are the following could be the probability of both A and B occurring at the same time, right? So we have options, for example, 0.2, 0.3, 0.4, 0.5, 0.6, and 0.7. Okay, let's think of this. First, see the maximum probability of if I see the maximum probability case, maximum probability of A and B. If probability of A is 0.5 and probability of B is 0.7, what is the maximum value of probability of A and B when A lies inside B? If this is A and this is B, so if this is 5, this is 0.2, and this is 0.3 to make whole one. So this is a maximum overlap, which is 0.5. So maximum overlap between A and B having a probability that is possible 0.5. This is a maximum case, right? Because probability of A is less than probability of B. So maximum case, you can make that you can put all of the values of A inside B. So that's the maximum overlap. You can't have maximum overlap of 0.7. For that, you need to add 0.2 in first probability, right? This is for the maximum. And now for the minimum, this is a bit tricky case. Now for the minimum, let's think that to minimize the overlap, we need to think a bit that if someone said that minimum overlap is 0, okay, if I consider this as a 0, so probability of A is 0.5 and probability of B is 0.7. So if you add both of these, what is the answer that is greater than 1, which is not possible? That means there must be some overlap between them. So how can we do that? If I call this probability of A and B, right? So if you understand the Venn diagram concept, the thing is, if you are dealing Venn diagram, always start from center. And this is the probability of A and this is the probability of B. So what will be this thing? This will be probability of A minus probability of A and B. And this will be probability of B minus probability of A and B. To minimize this thing, right, we need to consider that we have only 2 events. And if we are having only 2 events, the probability of A or B, if we consider this as 1, and only that scenario, we can minimize the overlap. So how can we minimize the overlap now? What is the probability of A or B in this scenario? Probability of A or B, which is equal to 1, and this probability of A or B is equal to probability of A minus probability of A and B. This is for the only A plus probability of A and B, plus this is the overlap part, and this is only B part, which is probability of B minus probability of A and B. This has to be equal to 1, right? So this 1 will cancel out, and this will be probability of A plus probability of B minus probability of A and B is equal to 1. So this will be 0.5 plus 0.7 minus probability of A and B is equal to 1. So this implies that probability of A and B is equal to 0.2, right? So there has to be minimum probability of 0.2 so that the overall probability sum can't exceed 1. And the maximum probability that is possible is only 0.5. So if I write this in form of range, that will be probability of A and B is greater than or equal to 0.2 and less than or equal to 0.5. So everyone got this?
Yes.
This is a scenario in which we are just provided with two probabilities and we need to find the possible value of AND. And now let's see the possible value for OR. And that is second scenario. There could be multiple scenarios based on this. I'm just giving you three scenarios as an idea, so that if you get any question just like this, you can just come up with such reasoning. And for example, if I say that probability of A is equal to 0.3 and probability of B is equal to 0.5, which of the following is the possible value for probability of A or B, right? For example, if I say 0.2, 0.3, 0.4, 0.5, 0.6, and 0.7. Again, we are asked to find the possible value, and this is a multiple choice option. So let's try to build up some range, the minimum and maximum value. And we are asked probability of A or B, right? Okay, let's see two scenarios in this. First is scenario A, in which the overlap is minimum. And scenario B, in which overlap is maximum. And probability of A given is 0.3 and probability of B given is 0.5. And what is the minimum overlap possible here? Because both of these sum, if we add this, probability of A, probability of B is less than 1. That means there could be a 0 overlap between them, right? So following this, we can say that if I consider the minimum overlap, so probability of A and B is equal to 0. So if this is 0, for us to find probability of A or B, that will be just probability of A plus probability of B, which is a mutually exclusive case. So probability of A is 0.3 plus 0.5, which is 0.8. This is a max value. And if I see the maximum overlap, so maximum overlap is 0.3 if A is inside of B. This is A, this is B, outside A, inside. So that is 0.3, 0.2, and outside 0.5. So max overlap is of 0.3. So in that scenario, probability of A or B is equal to probability of A plus probability of B minus probability of A and B. So this will be probability of A is 0.3 plus 0.5 minus the overlap 0.3, which is 0.5. So in this scenario, the probability of A or B has to be greater than or equal to 0.5 or less than or equal to 0.8, right? At first we discussed for the AND case, now we will discuss for the OR case. If I say that X and Y are independent events, and probability of X and Y is equal to 2 by 3. So can anyone tell what is the range for the value of probability of Y? We are just given that both of these events are independent, and we are given the AND probability, and we are asked that what is the range of the possible value of probability of Y. If, as first thing, these are independent, and in independent event, the AND probability is just the product of their probabilities, probability of X into probability of Y. And this thing is 2 by 3, and we are asked for the probability of Y. So let's think, what is the minimum possible value of probability of Y? The minimum possible value is itself 2 by 3, because if I consider this value less than 2 by 3, to make this equal to 2 by 3, this has to be greater than 1, which is not possible. So minimum value for this is 2 by 3, and maximum this could be equal to 1. Less than 1 or equal to 1. Getting the point? This has to be equal to 2 by 3 or greater than that. So think we can build out of this that probability of Y has to be greater than or equal to 2 by 3, so that we can get an overlap of this value.